mathworld.wolfram.com spherical harmonic. Oh, right here. It's in the it's in the. Okay. All right. So here's the plot. We represent the three-dimensional plots for the spherical harmonic. So this is. So all of these are for this one right here. This is for L equals 0, L equals 1. Okay. Oops, sorry. So that's L equals 0, L equals 1, L equals 2. Okay, not 2. L equals 2, L equals 3. Okay. All right. And these are for M equals 0. And this is, it's gotten messy. All right. All right. So this is M equals 0 over here. So this is L. So this is L equals 0, M equals 0. That's spherically symmetric. Okay. And that will turn out to be the spherical harmonic that goes with what we call the 1s orbital. Okay. And L equals 1. What do these look like? These look like the p orbitals you've seen in your freshman chemistry, right? So this is M equals 0 here. So L equals 1, M equals 0. You can, that becomes, when we get to the hydrogen atom, that becomes the spherical harmonic part for PZ orbital. Okay? And then your PX and PY. So instead of this donut right here representing +1 and -1, M equals +1 and -1, you have instead, okay, you have instead this one and this one, which looks just like the PZ orbit, the M equals 0 function, except that they're oriented differently. So this is aligned with the z-axis. This is aligned with the x-axis, and that's the y-axis, and this is aligned with the x-axis. This is aligned with the y-axis. The lobes for this are aligned with the x-axis, and the lobes for this are aligned with the z-axis. Okay, so remember from your freshman chemistry, px, that's py, I'm sorry, that's pz, this is px, and then you have your py over here. So the px and the py are linear combinations of M equals +1 and M equals -1. Okay? And if you take linear combinations of +1 and -1 for L equals 2, okay, there's 5 of those. You remember from freshman chemistry, you have your d orbitals come in sets of 5, dz squared. So this actually resembles what you would call your dz squared orbital. So you have 2 lobes and a donut around it, and then you look at your 4 lobes here for the others. So yeah, remember your dxz and dyz, and a dx squared minus y squared, and a dxy. So those are your 5 d orbitals. Okay, these are the spherical harmonics for those d orbitals. And then your f orbitals, these are the spherical harmonics for your f orbitals. They come in sets of 7. Okay, so only one of these have a definite m value, m equals 0. You have pairs of these would have be linear combinations of spherical harmonics that have the same m value. So if you combine the spherical harmonic with m equals +1 with m equals -1, you get an equivalent pair of real orbitals, real wave functions. Okay? So this is the list of This is the list of the spherical harmonics. And in terms of Cartesian coordinates, they're given here. You can see the +1 and the -1 right here, for example. Okay, it's complex. But if you take a linear combination of that, x plus iy and x minus iy plus, okay, x plus iy plus x minus iy, for example, your iy will disappear. So you get a real function. Okay? So you have plus iy for m plus 1, negative iy for m equals negative